Welcome back to my channel. Today we will be starting with the next topic of our chapter ellipse, which is the auxiliary circle. So consider the ellipse x square by a square plus y square by b square is equal to 1, where a is greater than b and b square is equal to a square in bracket 1 minus e square. This is an horizontal ellipse. It has the center C and the endpoints a and a dash, a comma 0 and minus a comma 0. If we have to draw an auxiliary circle, then consider this as the radius will be a. So draw the same radius here, and from the end points of this ellipse we draw a circle. This is known as the auxiliary circle, and the equation of the circle will be x square plus y square is equal to a square, as the radius is a. So consider a general point on this ellipse and a general point on this circle. Here we will connect this line and let it subtend an angle theta. So the point P, general point on ellipse, is written as a cos theta and b sin theta, and the Q point on this circle, any general point, is written as a cos theta and a sin theta. In ellipse there are two radiuses, so a and b will be there, but in circle the radius is same, so a and a will be there. Remember that circle is a special type of ellipse which has radius equal. It means that a is equal to b. Now if we substitute this a cos theta the whole square upon a square plus y square by b square is equal to 1. In place of x we just substituted the point a cos theta. So by solving this we can get the point of y, which is b sin theta. If we want to find the point P, which I have already told is a cos theta and b sin theta, so by putting a cos theta in here we can find the point y, which is b sin theta. The parametric form of the point P is a cos theta and b sin theta. Okay, I think now it's clear. So the parametric form of the point P is a cos theta and b sin theta. You have to remember this point. This is very important. Here theta is called an eccentric angle. Now for a horizontal ellipse we know auxiliary circle is x square plus y square is equal to a square. But for a vertical ellipse the auxiliary circle will be x square plus y square is equal to b square. Here the major axis will be the y axis, so the radius is b, and hence we have to find by radius b. So this will be the ellipse and this will be the circle. Here the radius is considered b, so by extending it here we can draw a circle by meeting the endpoints of the ellipse, and the Q, which is a general point on the auxiliary circle, will be b cos theta and b sin theta. It will be b here. The point P is to be written by the parametric form. Let's take an example. The first is x square by 25 plus y square by 16 is equal to 1. So what will be the center? As you can know, this is a standard ellipse. The center will be 0, 0. The foci, we know it is AE, 0 and minus AE, 0. To first find the eccentricity, we have to find it by this formula. E is equal to under root 1 minus b square by a square. Here b square is 16 and a square is 25. So by it we can get 3 by 5. Substitute it in here, and the a value is not 25. It's a square is equal to 25, so a will be 5. So multiply 3 by 5 into 5, which will be 3, and for s dash it will be minus 3. So 3, 0 and minus 3, 0. For directrix, the equation is x is equal to plus minus a by e. So the equation will be, so here a will be 5 and e will be 3 by 5, so that 5 will get multiplied here, so it will be plus minus 25 by 3. The length of major segment is AA dash and it will be 2a, which is 10, and the length of minor segment BB dash is 2b, which is 8. Ends of the lattice rectum are plus minus AE, plus minus b square by a. These are the ends of it, plus plus minus minus plus minus and minus plus, the four ends of lattice rectum, which will be plus minus 3 comma plus minus 16 by 5. The length of lattice rectum is 2b square by a, so by substituting we get 32 by 5. The parametric form of point P, this is the most important. It is a cos theta comma b sin theta. So a is 5 and b is 4. So it is 5 cos theta and 4 sin theta. Let's move on to our next example. In this, x square by 9 plus y square by 25 is equal to 1. Here we can see that a will be 3 and b will be 5. So it will be a vertical ellipse, not an horizontal one. So center will be 0, 0. Foci will be 0, b and 0, minus b. So find the eccentricity first, which is under root 1 minus a square by b square, which is equal to 4 by 5. By putting the value of e here and by substituting the value of b, which is 5, we get 0, 4 and 0, minus 4. The directrix is y is equal to plus minus b by e. So it will become y is equal to plus minus 25 by 4. The ends of lattice rectum are plus minus a square by b comma plus minus be. So they will be plus minus 9 by 5 and plus minus 4. The length of lattice rectum will be 18 by 5. 2b square by a by using 2a square by b. By using this formula, we can get 18 by 5. Your homework for today's session is to find the parametric form of point P of this ellipse. Comment down in the comment box. Hope you liked today's session. Thank you for watching my video. Do consider subscribing my channel and hit that like button. Also, share this video with your friends. Thank you.